Hello friends, welcome back to Edupedia Word Videos, your destination to free online education. We'll be starting a new chapter, a new topic in this video. The title of the topic is Area Related to Circles. Friends, we know that a circle has a figure like this, where the center is generally denoted by O. The perpendicular to the boundary is radius, denoted by R, small r, and when this perpendicular is extended to the other boundary such that this angle is 180 degree, we have the whole length PR as diameter. Now friends, what is the circumference of a circle? Friends, circumference is the length or the distance covered on traveling once round the circle. That is simply this length, this whole length will be the circumference of the circle. It is given by 2 pi r, where OR is equal to r units is the radius and diameter is 2r units. So it is also pi into 2r, that is pi into d, where d is diameter. The units will be centimeter or meter or millimeter, nanometer, kilometer, and so on. Now, what is this term pi? This term was given by the famous scientist, its value as Aryabhatta, and the value is 3.141592, so on, or simply it is 22/7 in fractional form. Some points regarding this pi are that it is an irrational number. That is, when 22 is divided by 7, we don't have a perfect integer. It is an irrational number. Moreover, it is non-terminating. That is, the expression on dividing this 22/7 never ends, and also it is non-recurring, non-repeating, or non-recurring. Similarly, we have another term related to circle. This was circumference. The other term is area. My dear friends, area is given by pi r square, where r is again the radius. The units will be in square, that is centimeter square or meter square, and so on. So all in all, we have circumference as 2 pi r or pi d or pi into 2r, and area as pi r square. Let us have an example on this topic. The question says radii is plural for radius. Radii of two circles are 3 centimeter and 4 centimeter. Find a circle having area equal to the sum of areas of these two given circles. So the area, let r small r denote first radius and capital R denote the second radius given, and we have to find out the area of the circle. Let the bigger circle whose area is to be found out, its radius be represented by r dash. So the sum of areas of given circles is pi r square plus pi r square, that is pi r square, here it is capital of R, plus r square, that is pi 3 square plus 4 square centimeter square. Or simply 3 square is 9 and 4 square is 16, so 16 plus 9 is 25. So we have sum of areas as 25 pi centimeter square. Now we have to find radius of the circle whose area is sum of the areas of this circle. So let the area of required circle be pi r dash square. Implies that pi r dash square will be equal to 25 pi centimeter square, or simply r dash whole square is 25 pi over pi centimeter square. Pi gets cancelled by in numerator and denominator being the factor, same factor on numerator and denominator. So we have r dash as plus minus 5 centimeter. Now length can't be negative, therefore rejecting the negative value, and the radius is 5 centimeter of the required circle. Let us have another example. The example says there is a game in which you have to land a ball in either of the three regions. If you land the ball in the first region, that is denoted by this, you will be the first. In the second region you will be positioned at second, and in the third region if you land the ball you will be positioned as third. The radius of the first circle is 7 centimeter, and each of this ring is separated by a distance of 7 centimeter. So let the center be O, this line be OR, the radius of second be OP, and the radius of third circle be OQ. So we have OR as 7 centimeter, OP as 7 plus 7, that is 14 centimeter, and OQ as 21 centimeter. The question says find area of each position, that is we have to find out the area for this first position or this second position or the third position. Let us first simply find the area of first circle, second circle, and third circle. Now area of first circle with radius OR is pi into 7 centimeter whole square, that is 7 square pi. Area of second circle with radius OP is pi into 14 whole square centimeter square, that is 14 square pi centimeter square. Similarly, area of third circle with radius OQ is 21 square pi centimeter square. Now, to be first, the ball should land in area in circle 1. Therefore, area is simply 7 square pi centimeter square, because this is the first position, the part of the first position. So it is 49 pi centimeter square. That is 7 into 7 into 22 by 7. 7 gets cancelled by 7, and we have 154 centimeter square as the result. Now, to be second, what can be the possible case? This is the reason included in the second part. So for this reason is area of second circle minus area of first circle. Now, area of second circle is 14 square pi, that is this, and area of first circle is 7 square pi. So all in all, we have pi as common and 14 square minus 7 square. Friends, it is unnecessary to calculate area at these stages individually, because you will see that here if you didn't calculate here, the calculation will somewhat be cancelled out or would have become easy. So bringing the 7 inside, we have 14 into 14 over 7 minus 7 into 7, that is 22. 14 into 14 over 7 minus 7 into 7 over 7, which gives us 14 into this 7 cancels 14, because 14 is the second multiple of 7, and we have 28 minus 7. On calculating, you will find that this value is 462 centimeter square. Now, to be third, this is the required region. So to be third, we have area of region as area of third circle minus area of second circle, that is pi into 21 square minus pi into 14 square, because this was the third circle, this is the second circle. So you will see that pi is common, that is 22 by 7 is common, and we have the internal brackets as this. Bringing 7 inside, 7 cancels 14 and 21, and we have 22, 21 into 3 minus 14 into 2, that is 22, 63 minus 28. On simplification, you will see that the calculated result here is 770 centimeter squares. So friend, this was another question, the application of the formulas. Let us have another question to clarify the two formulas. The question says wheel of a car have that is diameter as 80 centimeter. How many revolutions can each tire make in 10 minutes if the car is moving with speed of 66 kilometers per hour, it is 66 kmph. So here the tire of the car is having diameter as 80 centimeter, therefore radius will be 80 over 2 d over 2, that is 40 centimeter or 0.4 meters. Now the distance covered by this car will be nothing but the circumference or the multiple of the circumference. See, if this is the road and the tire, say this is the point A. Now car is starting at A point. After the rotation, the A has reached over here, and the rotation is again here, the A has reached here. So at this point A has reached this stage. So this distance A dash A will be nothing but circumference of the circle, because the circumference has traveled, the tire has traveled. So one revolution distance equal to one circumference, that is 2 pi into r, or 2 into 20 pi into 0.4, that is pi into 2 into 4 over 10, or 4 pi by 5 centimeter. Now this is the distance in one revolution. So let the tire made n revolutions. So the distance covered will be n into 1 revolution, that is n into 4 pi by 5 centimeter. Also the speed has been given as 66 kilometers per hour, that is in 1 hour we can travel 66 kilometers. Here it was meters, or 66,000 meters, because 1 kilometer is 1000 meters. So in 60 minutes, how much we have traveled? We have traveled 66,000 meters. So in 1 minute we'll be traveling 66,000 over 60 meters, or in 10 minutes we'll be traveling 10 times of this, because in 1 minute we was traveling 60th part of this thing. So 10 times of this is this. So in 10 minutes we have traveled, if we simplify, we have traveled 11,000 meters. Also, according to this revolution formula, we have traveled n into 4 pi by 5 meters, if we have made n revolutions in 10 minutes. So the distance, comparing the two distances, we have the distance traveled in n revolutions in 10 minutes equal to the distance traveled in 10 minutes with the speed 66 km per hour. So We can now easily calculate n, which will come out to be 11,000 into 5 over 4 pi. That is 11,000 into 5 over 4 into pi, which is 22/7. On cancelling, you will see that we have got 7 5s are 35 into 125, which is 4375. So the car, each tire of the car has traveled 4,375 revolutions. No doubt the car has 4 tires, but each tire covers the same distance. That is, each tire should have covered this 11,000 meter to reach the 11,000 meter. We can't say that first tire has covered 5,000 meters, second tire has covered 2,000 meter. It is not a disassembled car, it is a proper assembled car. So each tire will be covering the same distance, contributing the same part of 11,000 meter to travel the whole distance. So each tire has revolved or made 2,375. So friends, this was the introductory video on areas related to circles. Thanks friends for watching this video. In the upcoming video, I'll be covering sector, quadrant, etc.